Good afternoon, all of you. Today we will discuss about the data structures in second BSc Computer Science students. First of all, data structures. What is data structures? In fact, data is a collection of raw material. Already known, data is a collection of raw material. Uh, what is data? Data is a collection of raw material. That means that we have give any instruction to the computer is called input or data. After processor data is called as an output. Okay, clearly. The data structure name indicates itself the organizing the data in memory. Organizing the data in memory. Organizing the data means, for example, we have also learned the concept of arrays. Array means int a of 5 means a of 5 means in array name is a, that 5 elements are stored into an array. That means a of 0, a of 1, a of 2, a of 3, a of 4. That means a of 0 to a of 4 contains 5 elements. Here an array is a fixed size that cannot be increased or decrease the size of an array. So in these 5 elements are stored into an array. That means int a of 5, 10, 20, 30, 40, 50. 5 elements are assigned to the places. Array places means a of 0 is assigned to the 10, a of 1 assigned to the 20, a of 2 assigned to the 30, a of 3 assigned to the 40, a of 4 assigned to the 50. These are called organizing the data in memory. Here, where the 50 is stored into a particular memory, that means 50 is stored into the a of 4. There are many ways of organizing the data in memory, as we have already seen one of the data structure, that is arrays in C language. Okay. Array is a collection of elements one after another in sequence, that is stored one after another in sequence. We say that arrays are stored into the contiguous memory or continuous memory. The data organization of data is done with the help of array data structures. With the help of array of data structures. Okay, this is called as an organizing the data in a memory. For example, like simple example, in your house, uh, uh, valuable items are stored into the secret area. That means gold or jewelry or cash or anyone. But remote and comb or any pens are stored into table or bench, whatever it is. Here, two differences are there. One is valuable items are stored into organizing the data into organizing the data into particular way. But uh, uh, in daily life, we use pencil, pen, paper, whatever it is, remote control. These are the bench or books. Here, organizing the data or inorganizing the data. Organizing the data means particular way of data stored into the computer memory. Particular data are stored into the computer memory, like arrays. Okay, in like arrays, for example, uh, data structure means particular data into the array. That means here we have to for example, in this example, data structures means two data structures are characterized into two types: from two data structures and non from two data structures. That's means from two data structures are also known, that is integer, float, character, double are called as the primitive data structures. We have also learned in non-primitive data structures. that is characterized into two types: linear data structure and non-linear data structures. Linear data structures may be two types: static or dynamic. We also learn static means constantaneous. For example, array. An array is a fixed size. It cannot be increase or decrease the size of the dynamically. Size of dynamically. We have also introduced the new concepts of non-linear data structures with dynamic, that is linked list, stacks, and queues. Non-linear means trees and graphs. Okay, for example, in these data structures, okay, once again I will once again I tell you the concept. Data structures means organizing the data into a particular way of computer's memory is called data structure. Data structures are derived into two types: primitive data structures and non-primitive data structures. Primitive means primitive means already known, that is integer, float, double, character and long double access. These are called the primitive data structures. Non-primitive data structures are divided into two types: linear data structures and non-linear data structures. Okay, particularly linear data structures means that is characterized into two types: static and dynamic. Static, it is a constantaneous. That means an array is a array. Array means fixed size. It cannot be increased and decreased size of array dynamically. That means non-linear means dynamic. Dynamic means list, stacks, queues. Non-linear means trees and graphs. Firstly, we will discuss about linear data structures. That means dynamically. Linked list, queues, stacks. In drawback of array is also known. What is drawback of arrays? An array is a fixed size. It cannot be increased or decrease the size of the array. Once again, we have to change the empty place, or once delete the variable of an array, the place is empty. Where the place is empty, that means to overcome the problem of using linked list. Linked list means the deleted place where the particular element is deleted, the deleted place is identified. That means linked list. Linked list means linking the element of one after another. Another. For example, linking the element of array. That means, okay, linear data structures is said to be combined to any form of specific order. There are two techniques of representing linear structures. Okay, that means array linked list. What is it? Already discussed. Linked list means in arrays, drawbacks of arrays means uh, it cannot be increased or decrease the size of an array. To overcome the problem using the linked list. Linked list means, for example, in arrays, once the element is deleted or empty, it cannot be identified. In linear linked list, array empty place is identified by the linked list. So the empty place is filled with another element because of head node and data node and address node. Data node means one element before and another element before. That means, for example, In this linked list example, here three elements are there: 100, 200, and 300. 100 places A of 0, 200 places A of 1, and 300 places A of 2. A of 0, A of 1, A of 2. Here three elements are there. In these three elements are connected one another in another, one to another. For example, here 100 is connected to the 200 and 200 is connected to the 300. Here one element identified the address of another element. One element identified of another element, identified another element. Here last element is null. Null means nothing. Here only three elements are there. This is called as head node. This is called a tail node. Tail node means null. Null means nothing. End of the list. These are called here three elements are there. Okay. Address is identified another. Here, for example, 200 is deleted. Here the place is, for example, here 200 is deleted. 100 is identified by the this element and 300 is identified by this element in between 200. This is the advantage of the linked list. This is called as an linear data structure in dynamic. Dynamic means linked list. Next one, stacks. Stack means an array is a stack is a collection of elements. Stack means, for example, here 100, 200, 300, 400, 500. A of 0, A of 1, A of 2, A of 3, A of 4. Stack. A stack is a collection of items. A stack is a collection of items into which the items may be added or deleted at one end. Only call it the top of the stack. For example, one pile of a books in a pile. For example, 10 books of 10 books contain a bag. 10 books contained in a bag. Here 10 books, one book is deleted or added at the one end. That means top end. That is called as a stack. A stack is a collection of items into which the items may be added or deleted at one end. Only call it the top of the stack. Here 5 elements are there. One is A of 0, A of 1, A of 2, A of 3, A of 4. Okay. Here A of in this array, A of, for example, A of 4 is deleted. For example, A of 100, 200, 300, 400. 400. Here 400 is deleted. Which end? Top end of the stack. Okay, clearly this is called as in last in first out. Whenever the last element is deleted, whenever the last element is deleted, the top end of the stack, only elements are added or deleted only one end. Elements are deleted or added only one end. That is the top of the stack. That is called as a LIFO, last in first out. Last in first out. For example, okay, clearly, okay. Once again, a stack is a collection of items into which the items may be added or deleted at one end. Only call it the top of the stack. That is called as an, here the top place means 500. 500 means A of 4. A of 4th place is the top element. Here added or deleted only this place also called stack. This is called, so this is called as in last in first out structure. So it is called as an LIFO. Last in first out means LIFO. This is called as an stacks. Okay. Another example of another in dynamic data structures. So in linked list is also clear, stack is clear. Also queues. What is queue? A queue is a data structure. Queue is also a data structure. A queue is a collection of items into which the items may be added or deleted both ends. For example, in a railway reservation counter or queue, whatever it is, a queue contains only 10 elements. A queue contains only 10 members. For example, simple example, a queue contains 10 members, but processing is done on front node and adding our rear of the queue. That means First person is completed the ticket. First person is out of the queue. Second person is moved to the first place. Third person is moved to the second place, and last 10th person is moved to the 9th place. Here new person is added to the where the place, that means 10th place. Okay, here both ends. Deleted means only one end, adding means another end. That means both we are using the both ends. We are using the both ends. That is called as an first in first out principle. Here follows first in first out principle. First means deleted item is called as an front, and adding item is called as an rear. Here two new words is used, front and rear. Front means deletion, rear means adding. That is called as a queue. A queue is a data structure. A queue is a collection of items into which the items may be added or deleted at one end only, call it the top of the stack. Okay, here a simple example is there. For example, here in this example, 10 elements are there: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Here 10 elements are there. First person, A of 0, A of 1, A of 2, up to A of 9. A of 0 to A of 9 means 10 members into the queue. For example, here 10 element is deleted. 10 element is deleted. 20 is moved from the 10, and 30 is moved from the 20. 40 is moved from the 30, and 100 is moved from the 90. Here place is empty. Adding new element is added to the last one. This is called as a rear. Deletion is called as the front end. That is called as an front. Okay, here two words is used. This is called as an queue. Okay, this principle is called as an FIFO, first in first out. First in first out means FIFO queue. This is called as an queue data structure. Okay, this is called as an linear data, linear, and this is called a linear data structure. Dynamically means here a linked list, stacks, queues, and again, and once non-linear data structures. That means trees, graphs, and okay, so trees, graphs. Here trees. What is tree? Tree is a hierarchical structure. Hierarchical relationships meaning already known. Hierarchical means parent-children relationship. Parent-children relationship. Here parents are connected to the children. Children are connected to the parents. Here root node, branches, and sublinks, whatever it is. Here inheritance concept. Okay, here trees. In the for example, in trees, that often contain a hierarchical relationship among various elements. Hierarchical relationship, that means parents and children. Parents and children. For example, here bank. In this example, bank example, recurring deposits and savings accounts and withdrawals are there. Here three are the parent node, root node means bank. Children nodes are the savings account, withdrawal, and also sublinks are there. This is called as an hierarchical relationship among the elements. That data structure that reflects this relationship is termed as a rooted tree graph. Rooted tree graph. It is a hierarchical relationship. This is called trees. A tree is a, once again, a data often contain hierarchical relationship among various elements. The data structure that reflects the relationship as termed as a rooted tree. Okay, next one, graph. A graph sometimes varies between the pair of elements. Pair of elements means pair of elements. For example, in mathematics, space contains one element that is called as the. It is not to follow the hierarchical structure. Only root element and branches. Also, this relationship is called graphs data structures. This is called data structures. Okay. Okay. Thank you once again. Clearly follow. Okay. Thank you.